All right, greetings everyone. The purpose of this video is to go over some of the details from the final problem on your section 5.1 homework. It's called the radio transmitter problem. And it's a really good problem. It kind of shows some applications of all the different things we've learned in this section. But it can also be a very frustrating problem because it's pretty long and takes there's a lot of details as you work through it. So let's look at an example of it. So we're told that a small radio transmitter broadcasts in a 20-mile radius. And if we drive along a straight line from a city 25 miles north of the transmitter to a second city 23 miles east of the transmitter, we want to know during how much of that drive, in terms of distance, will we be able to pick up a signal from the transmitter. And this handout that you're looking at is available on WAMAP and is a good way to kind of be guided through the problem and also kind of give you a clear idea of what is going on with it. Okay, and the first part of this, which is important with any problem of this type, is to draw a picture. So I'm going to do that on the set of axes here. Now, first of all, as you notice, some of the numbers in the problem, 20, 25, they're kind of big. So on my graph here, I'm actually going to make things count by fives. So this will be 5, this will be 10, this will be 15, 20, and 25 up to there. And then you can imagine if we put tick marks on these other sets of axes that they represent the same thing. Okay, so now let's go about drawing the picture related to this problem. We first have a transmitter that is broadcasting a signal in a certain radius around where it is. So hopefully you would agree with me. It makes sense to start by putting the transmitter, which I'm going to call T, right there in the center. And if it is transmitting 20 miles in every direction, well, that means it can go out as far as 20 miles to the north, 20 miles to the east, 20 miles to the south, 20 miles to the west, and then 20 miles northeast, northwest, really any direction. And hopefully you start to see then basically what we get is this kind of circular shape that is the area where the signal can be picked up. And notice that the circle there is kind of the boundary of where it can be picked up, but inside of that you would also get a signal from the radio transmitter. Okay, and the next part. We're driving along a straight line from a city 25 miles north. So we're starting, say, up here, 25 miles directly north, to a second city 23 miles directly east. So that would be over here somewhere. And again, we're told we're doing this in a straight line. So what we're looking at here, that green line I just drew, okay, so that would be the path of the car or the vehicle. We want to know during how much of that drive in terms of distance will we pick up a signal. So let's first also think about in terms of this picture, where is that represented where we get the circle? Well, notice that's going to be this area I'm highlighting right here, right? The parts of the green line that are both intersecting with the circle and on the inside of it. Okay, so that's kind of our goal. And believe it or not, to find that distance there, that involves all techniques that we've used in section 5.1. Okay, so I'll let you work through the rest of the handout to help orient yourself better with the problem. I will show you where this handout is available on WAMAP. So if we go now to our class WAMAP page, which will look something like this. If you scroll down and open the chapter 5 folder, and then the class assignments and handouts folder within chapter 5, you'll see first of all, the first thing you see is a transmitter problem worksheet. So that's the handout you were just looking at. And then as well, a transmitter problem example solution. So as you're working through your version of this problem, if you get stuck, that could be a good resource for you. Okay. All right, that's it for now. Thank you for watching.